Hey everyone, ready to tackle a topic that's both mind-blowing and, well, kind of a head-scratcher.
I'm ready. Let's hear it.
Today's deep dive, time travel. It's captured imaginations for ages, and we're going to go beyond just, the sci-fi stuff.
Sounds like fun.
We'll be digging into some real science here. Using this article, we'll call it the time travel article. Fair enough.
Sure thing.
Fair warning, though, this gets pretty complex, but we're going to try and keep things fun, understandable. You know us.
I think we can manage that. Time travel is a topic that, well, it really pushes the limits of what we currently understand about the universe.
Exactly. And speaking of pushing limits, whenever I hear time travel, one name always pops into my head, Einstein. Did he actually, crack the code on how to bend time?
Well, maybe not a step-by-step time machine blueprint, but his theories of relativity were definitely game changers. He basically said that time, it isn't this fixed, unchangeable thing.
Oh, okay. So not like a clock ticking away, always at the same speed?
Right. Instead, he proposed that time is flexible, and it's all woven together with space to form what we call space-time.
Space-time. Okay, trying to visualize that. So like a giant fabric that can bend and warp.
Yeah, that's a good way to think about it. And actually, the warping of this space-time fabric, that's what we experience as gravity.
Whoa. Okay, so how does all this tie back to time travel, though?
Well, one really interesting result of this flexible space-time, it's something called time dilation.
Time dilation. That sounds trippy.
It basically means that time, it can actually pass at different speeds depending on your relative motion and how strong the gravitational field is where you are.
Hold on, so you're telling me time isn't constant for everyone?
Exactly. Picture this. You're on a spaceship going super fast, close to the speed of light. Time would actually slow down for you compared to someone who's stayed back on Earth.
Wait, so if I zipped around space for a while, I'd come back younger than, say, my twin brother?
Well, yeah, theoretically.
That seems a bit unfair.
It does, doesn't it? And while we can't quite hit those speeds yet, there's proof that time dilation is a real thing. They've done experiments with atomic clocks flown on jets.
Seriously?
Yep. Those clocks, they tick just a tiny bit slower than identical clocks here on the ground.
So technically, anyone who's been on a plane has done a little bit of time travel, even if it's just like a fraction of a second. That's wild. But now I'm thinking about all those sci-fi movies with super fast spaceships. Are those onto something, or are they just, making things up?
Well, some sci-fi gets pretty creative for sure, but there are definitely elements based on actual science. Like, take wormholes, for example.
Oh yeah, those cosmic shortcuts. Beam me up. But are wormholes actually a thing, or is that pure fiction?
That's where it gets, well, a lot more theoretical. Einstein's theories do allow for the possibility of wormholes existing.
So they could be real.
Potentially, but to create one or even to keep one stable, we'd need something we've never actually found. It's called exotic matter.
Exotic matter. Doesn't sound like something you'd find just lying around.
Yeah. It would need to have what's called negative energy density, which is really hard to wrap your head around. We've never seen anything like that in the real world.
So we need something we've never even seen to maybe possibly build a time machine.
Yeah.
Okay, big roadblock there. But let's say, just for fun, we somehow find this exotic matter. Can we then just hop into, a time-traveling DeLorean and go change history?
Not quite that simple. Even if wormholes were real and usable, time travel, especially to the past, throws a whole bunch of other challenges our way.
Like what? I've heard about paradoxes. That stuff
Yeah.
always messes with my brain.
Exactly. One of the most famous ones is the grandfather paradox. Imagine you travel back in time and whoops, you accidentally stopped your grandparents from ever meeting.
Wouldn't that mean I'd never be born? Talk about an awkward family reunion. But seriously, wouldn't that, mess up the whole fabric of reality?
That's the paradox. It shows how tricky cause and effect can be. The whole order of events that makes up our timeline. Changing the past, well, it could cause ripples we can't even begin to imagine.
Okay, yeah, that's definitely making my head spin. Are there any theories that try to, solve this paradox problem? Or are we just stuck with these mind-boggling what-ifs?
Well, there are some really interesting ideas out there. One comes from quantum mechanics, specifically something called the many worlds interpretation. This theory basically says that every little decision, every action creates a new universe. It branches off,
Whoa! So like a giant choose-your-own-adventure, but on a cosmic scale? Meaning if I went back and changed something, I'd just be making a new reality, not messing up my original timeline.
Yeah, that's the idea in a nutshell. But remember, this is still very much in the what-if stage. We're dealing with theories, pushing the limits of physics as we understand it.
So no time travel tourism brochures anytime soon.
Okay, but before we went down that rabbit hole, you mentioned closed time-like curves. Now that's a phrase that makes my brain tingle. What exactly are we talking about?
They're a pretty wild concept for sure. Imagine space-time curving so much that it actually makes a loop, like a path that leads back to an earlier point in time, a loop. So like a cosmic racetrack. You end up back where you started, but in the past. Gotta keep going around living the same day over and over.
That's a fun thought and definitely a popular idea in sci-fi. But if these curves exist, the reality is probably way more complicated. Plus, to make one, you'd have to manipulate gravity on a scale we can't even comprehend right now.
Okay, so no Groundhog Day time loop for me. But all this bending of space-time and gravity, it makes me wonder if there's anything out there, like in the universe, that's already doing this kind of time warping naturally.
You're thinking like a scientist. And you're right, there are some cosmic objects that warp space-time in extreme ways. Like black holes, for instance.
Those things are like the ultimate vacuum cleaners of space, right? Sucking in everything, even light, right?
That's right. Their gravity is so strong it distorts space-time around them, creating something called a singularity.
A singularity, does that mean, like, all the rules of physics just go out the window at that point?
Pretty much. Our current understanding of physics well, it breaks down at the singularity. Some physicists even think that the extreme warping of space-time near a black hole could, theoretically, create those closed time-like curves we were talking about.
So getting too close to a black hole could accidentally turn into a time travel trip. Now that's a scary thought. But let's switch gears for a bit. Another thing that's always fascinated me is quantum entanglement. Does that have any connection to time travel, or is that something else entirely?
It's a great question. And yeah, quantum entanglement is definitely one of the weirdest, most counterintuitive things in quantum mechanics.
Okay, for those of us who aren't quantum physicists, break it down. What is quantum entanglement, and how could it possibly be linked to time travel?
Okay, so imagine two particles that are connected in a special way. No matter how far apart they are, they share the same fate. If you measure the state of one, boom, you instantly know the state of the other, even if they're on opposite sides of the universe.
Hold on. So they communicate faster than light. Isn't that, like, impossible?
It's not communication as we normally think of it. It's more like they're intrinsically linked, they share a destiny, and that instantaneous connection, even across vast distances, has got some physicists thinking about potential time travel implications.
Okay, I'm intrigued. How could entangled particles maybe help with time travel?
We're still very much in the exploring the possibilities stage here, but some scientists believe that manipulating these entangled particles could allow us to send information back in time.
Information, not actual physical travel.
Exactly. Think signals or messages, not beaming people or objects through time.
So time-traveling emails instead of time-traveling tourists. Still pretty wild. But wouldn't that create a whole new set of paradoxes? Like, could the future actually influence the past?
That's the part that really blows your mind. It makes you question everything we think we know about cause and effect. If information can travel back in time, can the future shape the past? That's a question that's got both physicists and philosophers scratching their heads.
It's giving me a headache just thinking about it. It seems like the more we dig into this time travel thing, the more questions pop up. But I guess that's part of what makes it so fascinating, right?
Absolutely. It pushes us to the very edge of what we know and forces us to think in completely new ways.
Speaking of new ways of thinking, we've talked a lot about the science, the how of time travel. But what about the should we? I mean, if it became a reality, wouldn't that open up a whole Pandora's box of ethical issues?
That's a really crucial part of the time travel conversation, one we can't ignore. The potential consequences of changing the past, even with the best intentions, are almost impossible to predict.
Yeah, it's like, who gets to decide what gets changed? And what about the ripple effects? Could fixing one bad thing create something even worse without us realizing it?
Those are big questions. And then there's the question of personal responsibility. If we could go back and change our past choices, would we even be the same people? It's a slippery slope, for sure.
Messing with time feels like it could have some seriously bad unintended consequences. But what about traveling to the future? Would that cause the same ethical headaches?
It's a really interesting question. If you're just visiting the future, you're not changing the past, so you avoid those paradox problems. But it could still raise concerns about knowledge abuse, you know?
Okay, what do you mean by that? What kind of future knowledge could be dangerous?
Imagine coming back from a future where Say there's been a terrible environmental disaster. Do you tell people knowing it could cause panic, maybe even change the course of events?
That's a tough one. Do you try to prevent it, even if it means changing a future you've already seen? Or stay silent, knowing millions might suffer?
It's a real ethical dilemma. No easy answers there. So even time travel to the future, while it seems less problematic than going to the past, it still has its challenges.
This whole discussion has been mind-blowing. The science, the possibilities, the ethical minefield. It's a lot to process. But I have a feeling you've got one last thought to leave us with before we wrap up. Something for our listeners to chew on.
You're right, we've covered a ton, but the most important takeaway for me is this. Time travel, even just as a thought experiment, it makes us rethink what we know about the universe. And it forces us to face some of the biggest questions about existence itself.
It reminds us that there's still so much mystery out there, and that the boundaries of what's possible are always being pushed. Thanks for joining us on this incredible journey. We'll see you on the next deep dive.
Yeah, it really makes you think. We've talked about messing with the past, the risks, the ethics of knowing the future. But is there any way time travel could work without causing all these problems?
That's a tough one. It seems like time travel, no matter how you look at it, it throws a wrench in our whole idea of cause and effect, free will, even who we are as individuals.
Right. It makes you wonder if maybe, just maybe, time is something we shouldn't mess with. Like, what if we're meant to experience it this way, moving forward, learning as we go, no rewrites, no fast-forward buttons? There is something kind of beautiful in that, isn't there? Accepting the flow of time, the past, really living in the present moment. Time travel, even just the idea of it, makes you appreciate that perspective.
I totally get that. It makes you think about all those times you wished you could go back and change something. Would it really make things better? Or would it create ripples, change your life in ways you never imagined? Time travel really makes you realize how connected everything is.
Yeah, exactly that.
Well, as we wrap up this deep dive, I'm definitely feeling a sense of awe. And maybe a little bit of relief that time travel, at least for now, is still in the realm of imagination.
Agreed. It's been quite a journey, exploring the science, the possibilities, the philosophical what-ifs.
A lot to ponder.
And who knows, maybe someday our understanding of the universe will catch up to these ideas. Maybe they won't be so theoretical anymore.
But for now, we've got to keep asking the questions, keep exploring, keep imagining. Thanks for joining us on this incredible adventure into the mysteries of time travel. We hope you enjoyed this deep dive. That's it for today, folks. Catch you next time.